For question number 3, they're going to give us a sequence, 9, 4, -1, -6, and they're going to ask us some questions about this sequence. Now, to start things, I usually recommend, if you haven't already, to consider a table of values, just because I think tables are such a helpful way of picturing a sequence. If you don't want to, that's fine, that's totally up to you, but I always like to think of my n and t of n so I can remind myself of my variables, and then I'll remind myself the first number they give me in a list is the first term. The second number they give me in a list is the second term. The third term would be the -1, and the fourth term would be -6. Now, it does ask for us to write the explicit equation, which is kind of a review of what number 1 was about. Remember, question number 1 gave us both types of explicit equations, so we have notes there. An explicit equation for a geometric pattern is this one, with the initial value times the multiplier, power of n. Initial value plus or minus adder times n would be the pattern if it's an arithmetic sequence. So we do need to know what kind of sequence we have so we can tell which notes to use. But let's see if we can look at the pattern. 9 to 4, it doesn't look like it has a nice multiplier, so let's try subtracting. 9 minus 5, 4 minus 5, ooh, that looks like it's working, minus 5, yep, it seems like we found the pattern. We're subtracting 5. And since we're subtracting, not multiplying, this means that it must be an arithmetic equation. So I can steal from the example that I did up here in letter C, which was also arithmetic, if I need an example from question number 1 to do this. Now, to write the explicit equation, having a structure might help, and we said the structure was T of n equals the initial value plus or minus the adder times n. Notice regular n, not power n. So I'll look at this and I'll say to myself, okay, initial value. Ooh, they didn't give me that. They gave me the first term, which is nice, but they didn't give me the initial. I'd actually have to go backwards and predict what was behind the 0, even though I couldn't see it. And then backwards from the 9. What would have been there? If I was subtracting 5 and got 9, what number must I have started with? I must have started with 14. There's 2 ways you can get that. One, you can just kind of guess and check numbers until you subtract 5 and get to 9. That would work. Or you could reverse the pattern and add 5 to go backwards, which would also work. So it looks like we have the initial value. I'll sort of color code things here. The initial value was 14. And it looks like we have the adder because the pattern was subtracting 5. And that tips us off about the adder, including the sign. The fact that we're subtracting 5 means that the adder has a minus sign. So as I write my equation, T of n equals initial value, that's 14, minus, because it was subtracting, adder of 5 times n. We can feel pretty confident that we have what we need. Now, take a look at question letter B, because letter B is similar to, though not exactly the same as letter A. This one's giving you parts of a recursive definition. That's what we've been doing lately on the pages preceding this. So pages 16 and 17 that you did on Monday's lesson, and all of the pages last week that had to do with recursive, that's basically to lead you to this. So in letter B it says fill in the spaces. So there's a space here and there's a space here. I'm going to remember the fact that when I look at a recursive definition, I'm always seeing 2 things. The first thing should always be a specific term in the sequence. And I'm looking at this going, okay, it's saying -11 is a specific term. And the box is asking me which term number. Like, which term is it? Is it the first? Is it the second? Is it the third? Is it the fourth? Or so on. So I'm going to look at my sequence. And I'm going to realize I don't have a -11. So of course that makes us panic. Like, does that mean we're wrong? But then we remember the pattern and we say, oh, hold on, -11, that would just be the next number in the table. I just can't see it. So like if I keep subtracting 5, that's -1. Subtract 5, that's -6. If you subtract 5 one more time, the next number that you get is -11. And it would be the 5th term in the table. So in theory, we know that the 5th term is -11. And thus, in the box, we'll put a little 5 to show that's the 5th term. In the second part to the recursive definition, that's the part where we specify T of n and then what's happening in the pattern. So plus, minus, multiply, divide, etc. Going back to the pattern, we already said that the pattern was subtracting by 5. So right after t of n in my recursive definition, I'll write minus 5. Make sure that you chew on that. Make sure that both equation ideas make sense, because you'll need the equations to answer letters C through F. Before you watch the next video, try to look at each question and to ask yourself, which way would I do the problem? Which way would I be more familiar? Am I good at using the explicit equation, or am I better at using the recursive? Think about that, and then in the next video, I'll make sure I go through those parts.